Hi, Algebra 2. Let's do Module 1, Lesson 2. So first of all, let's multiply 28 times 7, but let's use an area model. So in other words, I'm going to make this multiplication represent the area of a rectangle. I think I might want to make this a little more representative so it looks like it makes a little more sense. Right? Because it should look a little more like that, right? If this is 20 and this is 8, then that's 20 and that's 7. Well, that makes more sense. All right, so the area of the rectangle, actually it's a square, in the upper right left-hand corner is 400. This one is 160, right? This one is 140, and then this one is 56. So essentially, we can write that 28 times 27 is equal to 20 plus 8 times 20 plus 7, right? Which is going to be the same thing as adding up all of those separate areas. There it is. Which is going to be so do you see how if I was to FOIL that out, that's the same thing that I would get, right? I have 20 times 20 is 400, and 20 times 7 is 140, 8 times 20 is 160, and so on, right? Well, let's learn a new way to multiply polynomials. Okay, so look at this. We're multiplying x plus 8 times x plus 7. How did we get that x squared there in the box? That's x times x. X times x is x squared. The 7x is x times 7. That 8x there, right, is 8 times x. And the 56 is 8 times 7. So what am I doing? I'm multiplying my column and row, right? Forming a grid there. So then using that method, I'm able to say that x plus 8 times x plus 7 is equal to x squared plus 15x plus 56. All right, and we're going to use that tabular method right now. Here we go. So let's use the tabular method to multiply these. So what have I got? I've got 3 on the top, right? So I've got a nice rectangle there. I've got my 3 terms on the top. And then I'm going to put this x squared minus 5x plus 2 on the side. And I'll make a grid for that also. And now we're going to go ahead and multiply, right? So I'm going to take x squared times x squared, and that's what's going to go in this top left-hand box. So x squared times x squared. Remember, when you multiply exponents, when you multiply, terms that have the same base and different exponents, I'm going to add the exponents, right? So it becomes x to the 2 plus 2 power, x to the 4th power. And then x squared times negative 5x is negative 5x cubed. X squared times 2 is 2x squared. X squared times 3x is 3x cubed. 3x times negative 5x is negative 15x squared. And 3x times 3x times 2 is 6x. These are all going to just be the same, right? 1 times all of these things is not going to change it, right? 1 times x squared is x squared, and so on. All right, so now that I filled in my box, I'm going to have some answers come out. The way that I'm getting these answers is I am adding diagonally up and to the right. Okay? So there's nothing up and to the right of x to the 4th, so I'm going to just drop that out. And it's going to come out of my box. Now, in the negative 5x to the 3rd, there is a term up and to the right of it. And we're going to add those. So I'm going to add negative 5x cubed plus 3x cubed is going to be negative 2x cubed. And then the 2x squared has 2 other terms diagonally up and to the right. And so I'm going to combine those terms. 2x squared plus x squared is 3x squared. And then I'm going to add 3x squared to negative 15. So when I add all 3 of those, I get negative 12x squared. Right? Looking at the 6x, I have a like term up and to the right of it. It's negative 5x. When I add those, 6x plus negative 5x, or 6x minus 5x, is x. And the 2 has nothing up and to the right, so it's just going to come out. So it turns out that I could say that x squared plus 3x plus 1 times x squared minus 5x plus 2 is equal to, and look at it, we're just going on the numbers that we pulled out, or that we added to get to that are on the side. And we did it. Let's try the next one. All right. Let's go ahead and add these. Alright, so when we multiply, x squared times x squared is x to the 4th. X squared times negative 2 is negative 2x squared. X squared times 3x is 3x cubed. 3x times negative 2 is negative 6x. And 1 times x squared is x squared. And 1 times negative 2 is negative 2. Let's go ahead and have these things spit out our answer. Uh-oh. I have a negative 2x squared and a 3x to the 3rd. Well, that's not going to work. I can't combine those. Those have different powers of x, and they're not like terms. So something must have went wrong. And it's a real common mistake that people make. I'm going to show you what happened. It turns out that I have descending powers of x without any missing on the top, right? I have x squared, I have x to the 1st with that 3x, and I have x to the 0. But the problem is that on my right-hand side there, on the one that I just did and was messed up, I have an x squared and then a negative 2. I'm missing the x term in the middle. So what I need to do when I'm using this method is I need to put a placeholder for x. What's 0 times x? It's 0. So it's not going to affect my answer at all. Adding 0 to stuff doesn't really change it at all. But what it does, it allows me to add my like terms diagonally. Right, so x squared times 0x gives me the 0. X squared times negative 2, again, negative 2x squared. So I'm going to just continue to fill this in just like I did before, except for now I'm going to have a row of zeros. There we go. So now my x to the 4th is going to come out because I don't have anything to add it to. The 0 and the 3x cubed I'm going to add together. That's just going to give me 3x cubed. And now over here, negative 2x squared plus 0 plus x squared just gives me negative x squared. And 0 plus negative 6x is going to give me negative 6x. And then the negative 2 will just come out. So then I can say that that is equal to x to the 4th. See that? I'm grabbing the numbers from outside of my grid that I made. And those are the answers when I multiply. All right, there's a problem here in your module. Skip it. We will do this, though, because occasionally you're going to have an expression that has two variables, and sometimes it's easier to just go ahead and distribute. And some people prefer using the distributive property to the tabular method. And I also want to show you that too, just in case you're one of those people. However, you do have to know how to do the tabular method, because when we divide, we're going to do the reverse. Or we're going to go backwards with tabular method. We're going to do reverse tabular method in order to divide. So it's very important that you know how to use the tabular method to multiply. But when you're just trying to get stuff done and you like this better, this is okay. A lot of people really like that tabular method though, and that's good. All right, let's go ahead and distribute. So what that means is that this x term here, it's got to multiply everything inside of the parentheses that has the x cubed plus x squared y plus xy squared plus y cubed. All right. So x times x cubed is going to be x to the 4th. X times x squared y is going to be x cubed y. X times x y squared is going to be x squared y squared. And x times y cubed is going to be x y cubed. Y times x to the 3rd, or x cubed, sorry, negative y, is going to wind up being negative x cubed y. Negative y times x squared y will be negative x squared y squared. Negative y times xy squared will be negative xy cubed. And lastly, y times y to the 3rd, negative y times y to the 3rd is negative y to the 4th. Let's combine like terms. Is there another x to the 4th term in there? Nope. We'll just drop it down. Is there another x to the 3rd y term? Heck yeah. And those are going to cancel out. So, right, it's 0 when I combine those. So we're not even going to bother to write it down. Is there another x squared y squared term? Yep. And it happens to be the exact opposite. So that's going to be 0. Those will cancel. How about these two? Those will cancel as well. So all I'm left with is x to the fourth minus y to the fourth. And there we've done it. We have distributed. And that is all for this lesson. We're going to get lots of practice with tabular method of multiplying in class tomorrow. And that's what our classwork will be. We might actually spend a little extra time on this if we need to. I hope you all have a great evening. Thanks for watching.